Hello students, welcome back. We just went through a variation of parameters to solve this equation here. And it worked out okay, but still there's a question, is that the best way to handle it? Well, variation of parameter is probably the best way to handle the particular solution for linear equations with variable coefficients. But for constant coefficients like this, it's not the best. Usually it's not the best. Usually it's much better to go ahead with some educated guessing, plug it in and working out. Let's see, what are the eigenvalues here? Let's go back to the previous equation, step 1. What's the eigenvalue? 1 plus 2i. And is that what we have over here for this exponential? No, it's not. So what I'm going to do here is make this educated guess. Y of p is some constant times e to the t power. Plug it in and then find out this c value. And wait a minute, it's just the same thing, isn't it? Yeah, eigenvalue is just 1, so we just keep multiplying ones here. So c times, okay, those are the derivatives. Plug all those in there and let's see what you get. Y double prime is c exponential of t power, okay, minus 2 c exponential of t power plus 5 e to the t power, I forgot c here, is equal to e to the t power. That's the equation. So all these are the same because eigenvalue happens to be 1. So as a matter of fact, what we have over here is times 1 times 1, and then here times 1 squared. Those are hidden. So plug all those in, and then what do you have here? All these can be simplified into this equation. 1 minus 2 plus 5, so this is 4c e to the t power is equal to e to the t power. So what do you get? C is 1/4. What does that tell us? It tells us yp, particular solution, is 1/4 e to the t power. And then if we combine that with the solutions of homogeneous equation you just found out, this is the way the general solution look like. 8 times e to the t power cosine of 2t, that was y1, and then b times e to the t power times sine of 2t plus 1/4 e to the t power, and that is the general solution of this non-homogeneous system, non-homogeneous equation, excuse me. Let's see, from the first solution, step 1 is the same. So let's copy and paste the step 1 homogeneous part. And what we did is step 2 of the solution. So step 1 is common. Okay, variation of parameter, it looks like this. Homogeneous part, you have to do it anyway. Step 2, variation of parameter computation. And then step 3, solving the system of linear equations. Here, I use computer algebra system, but it became this complicated. And then final answer here. And then we have some checking process as well. Now, if you use the other method, I don't know what name it is, undetermined coefficient. That's the term our textbook author is using, I think. Yes, undetermined coefficient, page 379. If you use that, homogeneous part is the same as before, and then you just use coefficient C to make an educated guessing, and some take the derivatives and plug those in and find out the coefficient, and that's how we can find out the particular solution. If you have all the constant coefficient, the second method, undetermined coefficient method, is superior.